Voice of the Sea, learning from experts across the ocean. Welcome to Voice of the Sea. In this episode, we're in the French Polynesian island, Moorea, with researcher Stella Swanson, learning about the importance of sea urchins in maintaining the health of coral reefs.
Stella and Mimi, thank you so much for letting me tag along today and learn about the research that you're doing.
I am part of a research group that studies the recovery process of a coral reef. So Moorea is frequently disturbed and tends to recover within about a decade to being dominated by beautiful corals. So my research focuses on the role of sea urchins and how sea urchins can help the recovery process of a coral reef. We're at what's called Temae Beach, and we're on the eastern shore of Moorea. And in my work on sea urchins, normally I do a lot of work on the north shore. I'm studying the role of sea urchins in the recovery of corals. And incidentally, about a year and a half ago, I was doing some of my normal research on the north shore, and some of the other researchers that were working here kept coming to me, Stella, oh my gosh, you study sea urchins. There's a lot of sea urchins dying. This is really weird. There's lots of sea urchins dying. And my advisor, Bob Carpenter, was one of the researchers in the Caribbean when there was a big die-off of the sea urchins. He said, Stella, you study sea urchins, and there's a lot of sea urchins dying here. This is kind of reminiscent of what happened in the Caribbean. So I started to collect a bunch of data on the current sea urchin kind of status. Are there sea urchins here? Are there a lot of them? How are they doing? And this area here in particular used to have a ton of sea urchins, kind of similar to what it was like in the Caribbean back in the 1980s. So there was just this one species of sea urchin, Diadema, which is the same genus as that was in the Caribbean, was really common. And they were really dying about a year and a half ago. So my research here is to look at the impact of the mortality of those urchins and whether the reef is going to change.
And how are you studying that?
What I do is I have a series of patch reefs that I have tagged out here with just little they're actually sheep ear tags. I have those tags that identify an individual coral. And we're going to go out and we look at the entire community on each of these patch reefs. So we go there, we count every piece of algae, we estimate how much coral there is, how many invertebrates, how many sea urchins are there. Mimi's the sea urchin counting expert. And then we're also going to collect little small samples of algae that we're going to take into the lab and we're going to weigh. And this is kind of getting a really fine scale estimate of how the community may or may not be changing.
Because the algae are food for the sea urchins.
Right, so the algae are food for the sea urchins, and we would expect that because this sea urchin that was really abundant a few years ago is completely gone, we expect that there might be a lot more algae. And that's not actually what I'm finding so far. It's pretty interesting and it's pretty promising because we were a little bit nervous that when these urchins died off, we could have something very similar to what happened in the Caribbean. In Moorea, there are these recurrent disturbances. So there have been predator outbreaks, so these predators that eat corals, which in our case are this really large sea star, acanthaster, or the crown of thorns sea star, which we may see out here. They're pretty rare normally, but every 10, 20 years there happens to be this crazy explosion of the population where there's just thousands and thousands of them, and you'll just see them everywhere you go. Anyway, they eat live coral, and so they'll just go over and eat all of the tissue off of every coral they go past. And also in Moorea, there's a lot of cyclones. So periodically there's a cyclone every maybe 10 years or so. And in the most recent case, there was an acanthaster outbreak that ate all of the live coral. And then a couple years later, or maybe 1 year later, there was a big cyclone that hit the North Shore. And so a lot of the coral structure was still there, which is really important habitat for fish and other organisms on a coral reef. But then the cyclone came and wiped out a lot of that actual structure on the outside of the reef. But in Moorea, we know that the reef tends to recover within about a decade pretty normally, and so our research group is really focused on determining what factors there are that are unique to Moorea.
And you're hoping to maybe use that information to help other areas recover?
Yeah, exactly. Sea urchins eat algae, so a lot of times when you lose a lot of coral, then the algae really takes over. And one really big example of that was in the Caribbean in the 1980s. There was lots of coral, but there was a lot of really heavy fishing for many, many decades. And in the Caribbean, the sea urchins were playing a really important role, but nobody really knew how important that was until the 1980s. There was a big disease that came through and wiped out one species of urchin that was really common. And once they, like 99% of the population was wiped out in a lot of areas. And once that sea urchin was gone, the algae just took over the reef. So all of the coral was dead for a really, really long time. And even to this day, there is not a lot of recovery. So this is, decades later, there's not a lot of recovery. So I'm interested in how sea urchins here are able to control that algae and keep it from becoming basically an algal forest.
Do you have any hypotheses as to what's keeping the algae population in check?
Yeah, absolutely. We think that there might be just a bit more of an intact fish community here. There are a lot of variety of different kind of fish that eat algae here, and you'll see quite a lot of them out here. So we're going to put out some GoPro cameras on some of these patch reefs so that we can take these videos and analyze them in the lab for how many bites the fish are taking of algae. So that might give us an idea of how much algae is being consumed on a daily basis.
What's your role, Mimi?
I go and count the sea urchins and assist her giving her mallet and keeping all the gear together.
Yes, crucial role. If I don't have somebody to hold things and help me stay organized, it can be a bit of a disaster in the water. Especially when this looks really gorgeous, but we also work here when it is ripping strong current. So if I don't have somebody to help me with keeping things organized and putting everything away, then it can be a disaster. But Mimi is going to be the sea urchin expert for this entire expedition, so she's going to be counting all the sea urchins on every one of the patch reefs, which can be a bit of a task. Sometimes there are hundreds of them, and you have to keep track of which species it is, and it's a really important job.
So is there anything that I need to be concerned about before we head out into the water, any safety issues?
I would say just watch out when you set your hands on different things so that you don't set your hands on some urchins and stuff like that.
Occasional eel.
Yeah,
Occasional
that too, check holes and stuff like that.
What about in terms of me hurting the environment? Is there something I need to be aware of so that I don't harm the ecosystem here?
Potentially you could hit with your fins, you could hit the coral and different stuff and damage. So it's always about that ecotourism where you try to be careful and not touch everything too much and remove stuff.
Look but don't touch.
Yeah, exactly.
Okay. So before we can go take part in your study, you guys need to get your field gear together. Can you show me what you're taking into the field?
Yep, sure. Yeah, so we have a bunch of different stuff here. This is always kind of the hilarious part for me. We come here with our bikinis on and look like we're ready for a day at the beach. We have a cooler, but there's no food, there's no anything super exciting. So we have a bunch of GoPro cameras that we're going to set out. So we have the nice underwater housings attached to weights. We're not really going to attach them to the reef because we're going to wait just here on the beach and watch and make sure they don't get stolen or lost. We just weight them down and put them on a certain place. We have this float, which is a miracle for everything that we bring out there because we have to swim about 350 meters out, and it's a long swim if you're lugging bags of everything. We're going to have little Ziploc bags to collect the algae samples in, and we have a GPS and a map that is crucial to get where we are going. So again, I have all these patch reefs tagged out here. So these are all GPS points and the tag number. So we're gonna take the GPS, find where we're going, and we're gonna follow the GPS out to one of these points, and then we swim around from there.
And these numbers correspond to those sheep ear tags you were talking about.
Exactly.
This is actually my first time at Temae, and I've gone on a few dives on the North Shore. So yeah, this is exciting for me too because I haven't seen the urchins here yet. The weight belt helps you be less buoyant in the water so you can get to the bottom pretty easily without using up your breath. I'm not very good at keeping my breath in. Stella here is like a mermaid. She can keep her breath for a long time, so it helps me stay under for a bit longer than I can, but it takes practice.
Yeah, the less we have to work to get down to where we're going, the better, the longer we can hold our breath while we're there. So when we're working elsewhere, we do a lot of work on scuba with the tanks and everything, but here it's so shallow, and where we're doing our work is really shallow, and it's much easier. We already have enough equipment. It's a lot easier to do it just free diving. Okay, so where we're going is basically straight out that way.
University of Hawaii's Sea Grant College program, focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
You're watching Voice of the Sea. I'm at Temae Beach with Stella Swanson and Mimi Mousley, snorkeling their study site and studying coral, algae, and sea urchin populations.
I can take you to a spot over here where there's a lot of really nice the staghorn coral.
The study area is made of coral head colonies in a shallow patch reef network. Temae and this area of Moorea used to have a very large population of the algae-eating urchin called diadema. But last year, the urchins started dying off. Stella and Mimi want to assess the population of diadema urchins this year, and they also want to see how the coral is doing without very many diadema urchins around to keep the algae under control. Stella and Mimi have tagged each of the large coral head bommies with colorful tags to easily identify them. At each coral head, we looked for sea urchins and took samples of the macroalgae growing on the coral.
So I collect one from either side of the patch reef, and then I collect one from the top of it, and the fourth one is an extra one that I'm taking for microbial sampling later on in the lab. So this one has a lot of crustose coral and algae on it. The pink stuff that you can see.
The samples were put in baggies for later analysis in the lab. We also put out GoPro cameras to record fish behavior. Stella and Mimi want to know which kinds of fish and how many fish are feeding on the algae. We didn't see any diadema urchins while we were snorkeling. But the algae does not seem to be overgrowing the coral, and the patch reef network at Temae is pretty healthy. Stella thinks this is an indication of a healthy fish population. That was so beautiful. Yeah. It was really amazing. Just the patch reefs and all the fish and little urchins hiding in their holes. Really nice. Thank you so much.
I'm glad you came. It's a really beautiful site. We love working here.
So did you see kind of what you were expecting to see?
Yeah, pretty much. So I don't know if we didn't point out which urchins were which to you quite yet at this point, but all these sea urchins that you saw out there actually today were not the species that was common. So we didn't see a single one of the diadema that used to be super abundant here.
Wow.
So there used to be just around the base of those patch reefs, there would be hundreds of this black-spined urchin diadema, and we didn't see any of those today. So they don't seem to really be coming back at all, which is not that surprising. But also, good news, it looks like the algae is not growing in really strong either. So that's pretty good. Yeah.
So the urchins that I saw sort of in the holes on the coral heads, that's a different species.
That's a different species, and those ones kind of stay. They sort of stay in those crevices for the most part. They all sea urchins feed at night, so you're not going to really see them moving around. That's why people just think that's an animal. Wow, it sits there and does nothing most of the time when we look at them. But at night you'll see them grazing around. But that species that we were looking at there, they don't graze very far, as opposed to diadema, the one that used to be really abundant here. You will see them really moving around and making a lot of ground and eating a lot of seaweed. So. Yeah, so that was a different species that we saw. With the ones that are here, we're also interested in whether or not those were competing with diadema in the past. So potentially the populations of this species could increase. So we'll find out. We might be able to find out actually this time when we count all of these sea urchins. We'll see. We can compare that to data before the sea urchins died here.
Because you did count them previously.
Yep. Yeah, because I was already doing some work out here for my master's before diadema died off and for my PhD as well.
And can you tell that the fish abundance has maybe increased in response to the urchins going down?
I don't know. That's really hard to tell. That's something that hopefully we'll be able to get an idea on the videos about that. It seems like the fine turfing algae, which is what we're focused on, that we are collecting those little samples of, that doesn't seem to be a lot thicker or really changed necessarily, and that's what we have been finding so far, that hasn't really increased, and that's usually the first to respond. So usually within a week, a couple weeks, certainly a few months, you'll see a lot more biomass of that really fine turfing algae.
But that turfing algae, that's what the parrotfish and other of the algae feeder fish will eat, is that right?
Yep. They eat that, and then if there is the larger algae that eventually will kind of get established, depending on the species of that, some of that algae they'll eat as well. But that's why it's really important kind of at this sort of stage where the algae is really small, because once the algae gets established, they have these kind of defenses against herbivores where the fish are not going to want to eat them because they have chemicals that make them taste bad, or they are really tough to tear apart. So it's really important at this stage where the algae is kept down and it's not allowed to really establish. So I think the fish are doing a great job. It's pretty good.
Exploring Our Fluid Earth is the dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group. The award-winning Fluid Earth and Living Ocean textbooks are now interactive and online. New activities, updated content, and a teacher community. Exploring Our Fluid Earth is now freely available. Find out more at exploringourfluidearth.org. You're watching Voice of the Sea.
Have you been able to establish what was causing the die-off of those, the long spine urchin?
No, we haven't. And that's a really good question, and that's something that we really would love to know also. So we think that it could have been some sort of disease agent, so probably a pathogen that was carried in the water. But that's really just based on what we know about what happened in the Caribbean with the long spine urchin as well. We know that that was a waterborne pathogen, but sadly they never found out for certain what caused that mortality in the Caribbean either. So it's really difficult when these things kind of happen. It sweeps through, it happens really rapidly. It's hard to collect samples of sick sea urchins to contrast with healthy sea urchins. So we don't really know. We have a bunch of samples we've collected, and we're looking for collaborators to see if they can help us analyze these for the bacterial community and the viral community, but we'll see. We don't really know, and yeah, it's a big mystery. But it was a really successful whatever disease agent or whatever it was. It eliminated pretty much all of them. I think it's more than 99% of them compared to what we used to see out here.
And you're pretty sure it wasn't people just going out and collecting them?
No, absolutely not. We have, when I came here and this was happening, there were still a few dying, so I got to really see the process of the sea urchins dying, where they were behaving really abnormally. They were coming out of their crevices during the day, which is really unusual, as you saw there. They're always hiding during the day, and even when they're really in high density, there's lots of them, they aggregate together for protection and they're not moving around. But when they were dying here, they were really kind of crawling outside and doing really kind of risky behaviors. And the fish, of course, were eating them as well. But when you would look at one that had kind of crawled out of its space during the day, you could see a lot of lesions, like spines missing. They looked quite sick, and they would actually basically decompose kind of within the period of a couple days. It happened really rapidly, so I could collect really healthy looking sea urchins, bring them into the lab, and by the next day they had pretty much completely died. All the spines are falling off. And what was left out here during kind of the end of that mortality stage about 1.5 years ago was just the tests. So basically, like, looks like the shell of the sea urchin and the spines, all the calcified parts of the sea urchin were remnant there. So you could just see all these dead piles of sea urchin tests, sea urchin spines. It looked like pine needles coating the sea floor. So we knew that they were really dying really rapidly.
There weren't other species or organisms you were finding dead or washing ashore. It seemed to be specific to the sea urchin.
It was primarily the sea urchin, but that is a really good question because unlike what happened in the Caribbean here, there were other species that were dying of sea urchins, but not in the great densities. So it probably has something to do with the fact that there were so many of this species of urchin here that this disease or whatever it was could carry through the population really rapidly, as opposed to some other sites where they're a little more patchy. You see an urchin here, an urchin there of all the different species. This was the place where they were really common, that one species, and that they essentially were all eliminated. So we don't know yet either if the sea urchins that were dying on other areas of the North Shore and stuff, if we can see a change in the population there. It looks like the populations were pretty low to begin with, so it's a little hard to tell if, you know, the population was reduced very much. So we'll see.
Well, I can't wait to see what you find out. Thank you.
Us too.
Thanks for watching Voice of the Sea.
The Curriculum Research and Development Group in the College of Education at the University of Hawaii at Manoa. CRDG's training roots go back over 40 years. Through professional development programs, curriculum workshops, research on teaching methodology, individualized school and district training, and so much more. The Curriculum Research and Development Group, improving schools, improving education. CRDG.
Turn your love of the ocean into a lifelong career. Join NOAA, the National Oceanic and Atmospheric Administration, as we unlock the secrets in the deep oceans, track rapidly moving storms, model climate trends, protect and preserve our marine resources, and so much more. It's all in a day's work at NOAA. Find a career that makes a world of difference, enriching life through science, service, and stewardship. NOAA.
Healthy oceans are critical to our cultural, economic, and environmental sustainability in Hawaii. The ocean serves as a source of water, food, medicine, jobs, transportation, recreation, and energy. It controls climate and weather. Kosi Island Earth aims to share this ocean awareness by partnering with local scientists and educators to engage communities and schools in active science learning for an ocean-literate population. Kosi Island Earth is working to establish new avenues for connecting research scientists with educators and communities. Kosi Island Earth is enhancing the science and ocean literacy of our island residents and visitors. Kosi Island Earth is connecting scientific research, traditional knowledge, and ocean policy. Kosi Island Earth, bringing together university, government, research, and community partners to improve science education and ocean stewardship in Hawaii.